Hello everyone, welcome to MK Academic Solutions. So in this video, I am going to explain you Le Chatelier principle. So who is the Le Chatelier here? So he is a French chemist and he made a generalization to explain the effect of change in temperature, pressure, concentration on the state of equilibrium. Okay. So for example, a system is already present in equilibrium. So now we are going to disturb the state of equilibrium. How we are going to disturb the equilibrium? By changing the temperature or by changing the concentration or by changing the pressure. So when you change these parameters, what will happen? The equilibrium shift in the direction in which the change is going to neutralize, or the change is going to be nullified, or the change is going to be undo. So that is, if a system is in equilibrium, is subjected to a change of concentration, temperature or pressure, the equilibrium shift in the direction that tends to undo the effect of change. Okay. So how we can understand this very simple manner? So for example, we are going to take a balloon and you fill with the completely with air and you press one end. What will happen? The air which is present where you press it, that will go into the opposite side. Okay. So that is nothing but what here Le Chatelier principle. And also see here, let us assume we are having for example water is here. So now this is the full of water here we are having. Okay. So now here one tap is there, from top one tap is releasing the water. Okay. So here now this system is in what? Is in the equilibrium. So here how much water is coming from here? The same is going outside. Okay. Now again we are adding more amount of water. What will happen? The exiting amount also increases. Means when you add water here, the exiting amount also what it is going to be increase. Means one side we are going to do change, means another side it is going to do balance. That is nothing but what? Le Chatelier principle. Okay. Now let us go to the different factors which affect on the equilibrium state. So first, effect of change of concentration. What is the effect of change of concentration here? See here, for example, we are going to take a general reaction. A is gives rise to B. It is a reversible reaction. So here A is the reactant. And B is the product. A is the reactant and B is the product. Okay, let us assume here equilibrium is established. Okay, equilibrium is established. So after establishing of equilibrium, what we are going to do? If concentration of reactant is increased. How we can increase the concentration of reactant A? Simply you add the reactant A here. So already equilibrium is present. For that equilibrium only what we need to do? We need to add the some amount of A, which means we are going to increase in the concentration of A. So when you increase the concentration of A, so what will happen? So the concentration of A is more when compared to the equilibrium state. Concentration of A is more when compared to the equilibrium state when you add the concentration, when you add the some amount of A. So that what will happen? The excess amount of A is going to be converted into B. Extra amount of A is going to convert into B, which means how, in which reaction A is converting into B? Forward reaction. So here if concentration of reactant is increased, what will happen? Forward reaction takes place. And if concentration of A is decreased, A is decreased, concentration of A is decreased. So what we are doing here, concentration of A is decreasing. How we are going to decrease the concentration of A? Just remove the some amount of A at the equilibrium. So automatically concentration of A is going to be decreased. And what will happen here, the concentration of A is less when compared to the equilibrium state. So that what will happen, the product again starts convert into reactant and it attain again a equilibrium, which means concentration of A is decreased, means backward reaction is going to be take place. Backward reaction takes place. Okay. So concentration of A is nothing but A is the reactant here. Now come to the concentration of B. Concentration of what is the B here? It is the product. Okay. So here if you increase the concentration of product, so concentration of product is increased, concentration of B is increased. Let us assume concentration of B is increased. What will happen? So already system is present in equilibrium. So now what we are doing, we are adding some amount of B. So increasing means that only. Okay, concentration of B, we are adding some amount of B. So when you add the some amount of B, the concentration of B is going to increase. So again when you compare the equilibrium state, the concentration of B is more. So what will happen, to attain the equilibrium, the B is going to be converted into A, means B is converting into A means it is the backward reaction. So here backward reaction is going to be take place. Backward reaction. If concentration of B is decreased, concentration of B is decreased means how we can decrease the concentration of B? Simply by removing the amount of B after attaining the equilibrium. After attaining the equilibrium, if you remove the B, means the concentration of B is very less when compared to the equilibrium state. So what will happen here, the some amount of A again is converted into reactant. Some amount of A is converted into product B. So in which type of reaction A is converting into B, forward or backward? Forward. Okay, forward reaction. Okay, forward reaction. Right, children. So this is about the concentration of effect of change in the concentration. Okay, simply let us scrutinize all these things. Concentration of A. Concentration of A increases. Forward means simply what is the concentration, what is the meaning of A here, that also let us know. So if reactant concentration increases forward, if reactant concentration decreased, backward. Okay, next, if product concentration increased, backward. If product concentration is decreased, forward reaction is going to be take place. Okay, so this is the conclusion from the Le Chatelier principle. Okay, so next, effect of change in pressure. Okay, generally when we are having gases, what will happen? So pressure has effect on the state of equilibrium. Okay, let us assume here again we are going to take A gas, n moles of A gas plus or simply you take n moles of A gas and he gives rise to x moles of B gas, x moles of B gas. Okay. So, this is a reversible reaction, here gases are involved. Okay. Consider. Okay. Right. Now, effect of change in pressure. So, here different cases are there. Here case 1, delta Ng is equal to 0, delta Ng is equal to 0 means x minus n, x minus n equal to 0, x minus n equal to 0, x minus n. Delta Ng means that is only now. What is the meaning of delta Ng? Number of moles of gaseous products. Delta Ng means number of moles of gaseous products minus number of moles of gaseous reactants. Okay, this is only the delta Ng. So, now if delta Ng is equal to 0 means x minus n is equal to 0. So, there is no effect of change in pressure, no effect of change in pressure means so you decrease pressure or increase pressure, there is no effect on the equilibrium state. For example, you take H2 gas plus I2 gas, H2 gas plus I2 gas is gives rise to 2HI gas, H2 gas plus I2 gas is gives rise to 2HI gas. So, here delta Ng is equal to 2 minus 2, that is equal to 0. There is no effect of change in pressure. Why there is no effect of change in pressure if delta N equal to 0 means, children, here how many moles of gaseous products are there, the same many moles of reactants are present. We know 1 mole of any gas occupy 22.4 liters. So, these are also occupying the same volume, means product side also we are having same volume, reactant side also we are having same value. So, that is why there is no effect of change in pressure. Okay. Next, here case 2 we will see, delta Ng is greater than 0. So, in this case what will happen? Here x minus n is equal to positive value, greater than 0 means positive value only we are going to get. So, in that case if pressure increases, the volume is going to be decrease. Pressure increases, what happens here? Volume is going to decrease. Pressure increases, volume decreases. So, the equilibrium shift in the direction of reactants. The equilibrium shift shift in the direction of reactants, in the direction of reactants, Let us see here, let us take one example. PCl5 is gives rise to PCl3 plus Cl2. Okay. So, here what is the delta Ng? Here delta Ng is positive, plus 1 here you will get. So, means here how many moles of products are there? 1 mole plus 1 mole, total 2 moles of products are there, here only 1 mole is there. So, here all are present in the gaseous state only, in the gaseous state only. So, here what will happen? when you increase the pressure, so the volume is going to be decrease. So if volume is going to decrease, the equilibrium shift towards the less number of moles. Where we are having less number of moles? In the reactant side. So the products are going to be converted into reactant. So here backward reaction is going to be take place. Okay, so why? Because here less number of moles is there. So less number of moles of gas means less volume they are going to be occupy. Here more number of moles of gases means more volume they are going to be occupy. We already know 1 mole of any gas occupy how much? 22.4 liters at STP. Means equal volume of gases are having equal number of moles. That law also we know, right? So simply you remember, when pressure is increases, what will happen? Equilibrium shift towards in the direction where it is having more number of moles, sorry, where it is having less number of moles, where it is having what? Less number of moles. So here, so in this direction, if pressure is increased, means equilibrium shifting into the reactant side. Why? Because the reactants are having less number of moles. So in the same manner, if pressure is decreased, in this case only, if pressure is going to be decreased, pressure, if pressure is decreased, if pressure is decreased, what will happen? If pressure is decreased, volume is going to increase. If pressure is decreased means volume increases, volume increases. Pressure decreases means what happen? Volume increases. Volume increases. So if volume increases, what will happen, children? The equilibrium shift towards the product side. The equilibrium shift towards product side, towards the product side. Why? Because here if pressure decreases, volume increases, means so much volume is there to occupy. So in which direction we are having more number of moles? Product side we are having more number of moles. So that's why the equilibrium shift towards the product side. So product side means forward reaction is going to be take place. So forward reaction. So here forward reaction is going to be take place, okay, if pressure is going to be decreased. And next come to the case 3. Okay, case 3. So what is the case 3 here? If delta Ng is less than 0 means it is negative. So let us take here N2 plus 3H2, N2 plus 3H2 is gives rise to 2NH3, N2 plus 3H2 is gives rise to 2NH3. So here what is the delta Ng value? Delta Ng is equal to 2 minus 3 plus 1 4, that is equal to minus 2. So in this case what will happen? If pressure increases, volume decreases. So which side we are? Volume decreases. So the gas should occupy the less volume. Gas should occupy what? Less volume. So that equilibrium shift towards the product side. So in the product side only we are having less number of moles. So that the equilibrium going to shift into the product side. So pressure increases, volume decreases, means here forward direction it is going to be take place, or simply equilibrium shift towards the product side. Equilibrium shift towards product side, shift towards product, to shift towards product side. If pressure decreased, if pressure decreased means volume is going to increase. Now the equilibrium shift towards the more number of moles. Equilibrium shift towards which side? More number of moles. Where we are having more number of moles? At reactant side we are having more number of moles. So pressure decreases, volume increases means backward reaction, means more number of moles in reactant side is there, so that equilibrium shift towards the reactant side. So reactant side means it is the backward reaction is going to be take place, backward direction reaction is going to be take place, which means equilibrium shift towards the reactant side. Equilibrium shift towards reactant side, okay. So this is about the different cases. So now let us generalize this effect of pressure, means how we can generalize the effect of pressure. If equilibrium, if pressure changes, so here already I discussed with you, if delta Ng is equal to 0, delta Ng is equal to 0, no effect. Delta Ng is equal to 0 means no effect. Delta Ng is greater than 0, pressure increases. If delta Ng is equal to 0, so condition on pressure increases, volume decreases, pressure increases, volume decreases. So it will goes to the reactant side forward. If pressure decreases, volume increases, so product side, reactant side, it is the product side. Reactant side means you just remember it is the backward, product side means it is the forward. Next, delta Ng is less than 0, delta Ng is less than 0, product pressure increases, volume decreases, the equilibrium shift in the direction of product side. Now equilibrium shift towards the product side, more product is going to be formed, and if pressure decreases, volume increases, reactants, and more reactant are going to be formed here. This is about the effect of pressure. Or simply you remember, children, if you increase the pressure, equilibrium shift towards the less number of moles. So simply the effect of pressure, how we can remember? If pressure increased, so overall I am going to give conclusion here about effect of pressure. If pressure is increased, equilibrium shift towards the more number of moles. If pressure is increased, if pressure is increased, equilibrium shift towards less number of moles, and whereas if pressure is decreased, if pressure is decreased, pressure is decreased. If pressure is decreased, what will happen? If pressure is decreased, equilibrium shift towards the more number of moles. equilibrium shift towards more number of moles, more number of moles of gases. Okay, so this is the effect of pressure. So summary of this effect of pressure. Next we will see the effect of temperature. Effect of temperature, see here, in the effect of temperature we can take the reactions into two types: exothermic reactions, endothermic. Exothermic reactions and endothermic reactions. So in exothermic reactions, exothermic means heat is released by the system. What is the exothermic? Heat released, and here delta H is equal to negative, or this also we can represent as reactant is gives rise to product plus energy, or this represent as reactant minus energy is gives rise to product. So these are all the conditions of what? Exothermic reactions and endothermic reactions. Endothermic reactions, what is the endothermic reaction? Heat is absorbed, that is endothermic reaction. Delta H is positive, H is equal to positive, or reactant is gives rise to product minus energy, or reactant plus energy is gives rise to product. So these are the conditions of exothermic reactions and endothermic reactions. See here, temperature increases in exothermic reactions. Exothermic reaction means here equilibrium shift in the opposite direction. If temperature increased in exothermic reaction or temperature decreased, so both the conditions we are going to take. Here also temperature is increased, temperature is decreased, both the conditions we are going to take. See, in exothermic reaction, for example, we are going to consider A to B is the exothermic reaction. It is the, if forward is exo means automatically backward will become endo. Okay, so if forward is exothermic reaction means backward reaction automatically it will become endothermic reaction. So in exothermic reactions we are going to consider, in exothermic reaction temperature increases, backward reaction, backward means equilibrium shift towards the reactant side. If temperature decreased, forward reaction. Okay, if temperature decreased, forward reaction is going to be take place. Next, in endothermic reaction, so A to B is endo, we are going to consider. Again automatically B to A will become exo. So here forward is endothermic reaction and backward is exothermic reaction. So in endothermic reactions, temperature increases, forward reaction is going to take place. Temperature is decreased, backward reaction. Means here we are going to only change the temperature, remaining all the things we are going to keep the constant only. Okay, so this is about. So let us take one example here. N2 plus 3H2, is gives rise to 2NH3. All are in the gaseous state only. So here we know it is a forward reaction is exothermic reaction. Forward reaction is exothermic reaction, and here backward is what? Endothermic reaction. So here it is the endothermic reaction. Here forward is exo and backward is the endothermic reaction. So now if temperature increases means backward. Why? Because backward is what? Endo, means towards the reactant side it will come. If temperature decreases, forward. Reaction. If temperature increases, so which reaction is going to take place? Forward reaction is going to be take place. So this is the effect of temperature on the state of equilibrium. Okay, next we will see effect of addition of inert gas. Effect of addition of inert gas means we are going to keep temperature constant, pressure constant, and what we are going to do here, temperature constant, concentration constant we will keep. Temperature and concentration are constant. Okay. So now at this condition, if you add the inert gas, so addition of inert gas at constant volume. Okay, the condition 1 is here. What is the condition 1? Addition of inert gas at constant volume. So when you add the inert gas at constant volume, so here why we are adding the inert gas means inert gas is one which is not at all going to react with the reaction mixture or equilibrium mixture. Okay, so this is the equilibrium is established. Okay, so now here we are going to add the inert gas like helium, neon, argon, etc. When we add these inert gases at constant volume, there is no effect. Constant volume, no effect. Okay, at constant volume there is no effect. So whatever the case you take, delta Ng is equal to 0, delta Ng is greater than 0, or delta Ng is less than 0. Whatever the condition you take, no effect. There is no change in the volume, means there is no effect on the state of equilibrium at a constant volume. Okay, whatever the condition you take. Next you will see addition of inert gas at constant pressure. At constant pressure means, children, see for example here we are going to take a container, a flexible container we are going to take, not a rigid container. So in this flexible container what we are going to do, so here pressure constant. Okay, so what is constant here? Pressure is constant, but we are going to add the inert gas, addition of inert gas, we are going to add the inert gas. So what will happen here, when we add the inert gas, volume is going to be increased. Here we know formulas, PV is equal to nRT. Okay, so now here pressure is constant, R is constant, T is also constant, V is directly proportional to N. Means what is the N here? Amount of gas. So amount of gas we are going to increase, isn't or not? Amount of inert gas we are going to increase. When you increase the amount of gas, your volume is also going to be increased. So here what will happen here, when we add the inert gas at constant pressure, what will happen? Volume is going to be increased. So addition of inert gas leads to increase in the volume, increase in the volume. So if volume is increases, if volume is increases, what will happen? What will happen? So here it is depend on the type of reaction again. It depend on what type of reaction. So which direction it is going to be moved. So here delta Ng is equal to 0. Delta Ng is equal to 0. So no effect. No effect. Next, delta Ng is greater than 0. Delta Ng is greater than 0 means here more products are present, more number of moles of products are present. So here the increase in the volume will give some space for the products. So more number of products are going to be formed, means more number of products in which direction they form? Forward direction. Okay. Next, delta Ng is less than 0. Delta Ng is less than 0 means here more number of moles of reactants are present when you compare to the products. Okay. So here volume is going to what? Volume is going to increase. If volume is increases means automatically which side we are having more number of moles, that side only the equilibrium is going to be shift. So here delta Ng is less than 0 means here we are having more number of moles of reactant side. So that equilibrium is going to shift towards the more number of moles, means backward direction. Backward direction, the equilibrium is going to be shift. Okay. Next, let us see catalyst. Effect of catalyst. So what a catalyst can do, it can equally speed up the both forward as well as backward reaction. That's why there is no effect of catalyst on the state of equilibrium. No effect of catalyst. No effect of catalyst at on the stage of equilibrium. No effect. There is no effect of catalyst of the state of equilibrium. Okay, these are the state of equilibrium. Okay, so these are the factors which influence on the state of equilibrium and Le Chatelier principles. Okay, now let us summarize all these effects in a single table. Okay, stress, in which side we are giving stress, and the direction of equilibrium is going to be shift. So means one side we are giving stress means the equilibrium is going to decrease the stress by moving in another direction. Okay, see for example, increase in the concentration of reactant. If you increase the concentration of reactant, forward reaction take place, and increase in the concentration of product, backward reaction is take place. In the same manner, if you decrease the concentration of reactant, backward reaction takes place. If you decrease the concentration of product means forward reaction is going to be takes place. So increase in the temperature. Increase in the temperature towards the endothermic reaction means temperature decreased towards the endothermic reaction is going to take place, and decrease in the temperature towards the exothermic reaction means decrease in the temperature leads to exothermic reaction, increase in the temperature leads to endothermic reaction. Next, increase of pressure. So what happen if pressure is going to be increased? If pressure is increased towards the lesser number of moles of the gaseous moles, where means pressure is increased means the equilibrium going to shift towards the less number of moles of gaseous substances. Next, decrease of pressure. If you decrease the pressure, what will happen? Towards the large number of moles of gases. Why? Because pressure decreases, volume is going to increase. So where we are having more number of moles of gases, that side only it is going to be shift. Next, addition of inert gas at a constant value, no effect. Addition of inert gas at constant pressure towards the large number of gaseous moles. And next, addition of catalyst. So addition of catalyst is not having any effect on the state of equilibrium. Okay, so this is about the Le Chatelier principles and what are the factors which influence and the state of equilibrium. Okay, so okay, thank you for watching, and in the next video I will discuss about the applications of Le Chatelier principles.